So let's talk about AWS Lambda, concurrency, and throttling. So your Lambda function can have 1,000 executions that are simultaneous across your entire region. So that means that if you have a lot of load, you can scale to 1,000 AWS Lambda functions running at the same time. That limit can be increased through a ticket. So let's have a look at what it is. Basically, if we have a small load on our Lambda function, we may have two Lambda functions running at the same time. So two invocations of the same Lambda function running. You don't need to deploy a new function to have it scale. And so if we have a huge load, maybe we'll get a lot of invocations of the same Lambda function running at the same time. And so we've seen from the intro lectures, if you remember, that when we clicked on that little bucket before, it was generating more invocations of our Lambda, and so there was higher concurrency. Now it is possible for you to set a reserved concurrency at the function level, basically to say that the function should have at least a limited reserved capacity to be able to run up to, say, 100 functions concurrently at the function level. Now, each invocation of the concurrency over the concurrency limit will trigger a throttle. Okay, so if you say, I can only have 100 Lambda functions executing at the same time, and you have 100 running, and now there's a new request coming in, you would need to invoke 101 Lambda functions, and that doesn't work, so you're over the limit, so it triggers a throttle. And the throttle has a behavior based on how you invoke your Lambda function. If you invoke it synchronously, so for example from the AWS console, this is a synchronous invocation, then it will return a throttle error 429. And if it is an asynchronous invocation, it will retry automatically. And then if it retries too many times, it goes to something called the DLQ. Let's talk about DLQ or dead letter queues. So your Lambda function can be invoked either synchronously or asynchronously. If you invoke it synchronously and it fails for whatever reason, you are responsible as the caller to retry. And you could, for example, use something like exponential backoff to retry your function. If it is an asynchronous invocation that fails, automatically AWS Lambda will retry that invocation twice. And if after all the retries, it doesn't still work for whatever reason, your function fails, something goes wrong, then the unprocessed events will go straight to a dead letter queue if you set it up. So dead letter queue is DLQ. And we've seen that behavior when we used SQS. When we couldn't process messages from our SQS queue, we had the option to send straight the messages to SQS dead letter queue. So here for Lambda, the dead letter queue can be either an SNS topic, for example, if you wanted to receive, I don't know, an email notification, or an SQS queue if you wanted to have workers work on these requests and understand why they failed and maybe process them later. So here's an example. S3 is an asynchronous trigger. And so maybe we're talking about our little thumbnail creation service. So we upload an image and it turns out that our Lambda function cannot process our image. And so it goes into a retry loop. So we'll try twice again to process that image, and maybe it still doesn't work. Maybe there's something really, really wrong with that image in your S3 bucket. And so your Lambda function can send a message straight to your SNS topic as a dead letter queue or your SQS queue as a dead letter queue. And so you need to set that up and choose which one you want to happen. And then the original event payload will be sent to the dead letter queue, which makes it really easy to debug what's wrong with your function without changing the code. So for example, if we see that many of our images are not being processed and no thumbnails are being generated for those, and we don't have time to change the code, we can just set up a dead letter queue and find that these events end up straight into SNS or SQS to understand what's happening. The one thing you should know though is that because your Lambda function sends data to SQS or SNS, it needs to have the correct IAM execution role. Otherwise, it will not be able to write events to the dead letter queue. And that is actually quite a common exam scenario. Okay, let's have a look in the hands-on. Back in our function, we're able to scroll down all the way. And in the very bottom, we can see here for debugging and error handling. So here we're able to say if we want to have a dead letter queue. So we can choose Amazon SNS or Amazon SQS as a dead letter queue. So let's choose SQS. And in there, I'm able to select an existing queue. So we could use my first queue that we had created from before, or my first DLQ that we had created from before, or we can create a specific SQS queue just for this purpose. So for just simplicity's sake, I'm going to go ahead and choose my first DLQ just because it is one that we already created. As you can see here, we get an error message saying your existing role does not have permission, send message for this SQSQ. So if we go back, the execution role is Lambda basic execution. And currently it can only write to CloudWatch logs. But here we're also saying, hey, you should be able to write to SQS. So we need to change the IAM role to enable this send message permission. So let's click here to change the message permission. And so now we have our Lambda basic execution. And so if we click on this, we can see that there is the logs, create log group, create log stream, put log events. But we're basically able to attach a policy. And maybe I'll go to SQS and attach SQS full access. It is a bit strong right now, but let's just do this for simplicity's sake. I'll attach the policy. And now our Lambda function is able to write to SQS and do way more than this, but this is fine just for this tutorial. So now, basically, we have enough permissions to write to SQS. So we can probably refresh the page just to see the error go away. Let's refresh the page and scroll down. Go back to the DLQ resource, click on SQS, and select my first queue. And now, as you can see, there's no error message. I'll go ahead and save this. And let's scroll back up. As we can see now, our Hello World is now integrated with CloudWatch logs and also Amazon SQS. So by adding the permissions, the designer noticed that we are going to integrate our Hello World function with CloudWatch logs and SQS. Now let's scroll back down and we can have a look at concurrency. So here, as told you, across your accounts, you have 1,000 concurrency limit, but you can either use the unreserved account concurrency to run your function, or we can reserve the concurrency and say, okay, this hello world function should only run at a maximum concurrency of 20. And if it goes over 20, I want errors and I want it to throttle. So I'll click on save and it's saved. You could also, if you wanted to, click on throttle just to test the throttle behavior. And this sets the reserve concurrency for hello world to 0. So this is just for emergency, but let's have a look and click. So now the function is throttled and the reserved concurrency is 0. And so now if we invoke the function, click on test, we should see that calling the invoke API action failed because we have exceeded the rate. So this is a throttle error. And the reason is because we have our function being throttled. So if I click on test again, it will not work, obviously. But if I go back to the reserve concurrency and say, okay, I want to have 20 functions running at the same time, I'll save it. And now I click on test. Now our functions succeed and we're able to run it.